Lesson 4.8, Solving Quadratic Equations Using the Quadratic Formula, Example 2. For our second example, we're going to start with 25x squared minus 18x equals 12x minus 9. Again, going through my methods of solving quadratics, I know I have factoring, which might be a possibility, square roots, which is not a possibility because of the x terms, and quadratic formula. So because I have two possibilities and they both involve setting equal to 0 to start, we're going to do it that way. We're going to subtract 12x and add 9 to move everything to the left side. If I were to move everything to the right side, that would give me a negative leading coefficient of negative 25x squared, which would make things a little bit trickier. So we now have 25x squared minus 30x plus 9 equals 0. From here you can look to take out any common factors, which I do not have. And it does not look like something that's going to be easily factorable, since my leading coefficient is not 1, although it is factorable. So if you choose to factor it, you would also be able to get the correct answer. It does follow the perfect squares pattern formula. Or you could guess and check, which is the other method that we've talked about. Since we are using the quadratic formula, though, in this lesson, we are going to go ahead and use the quadratic formula. So I'm going to set up A, B, and C. And from here, we're going to plug it directly into the quadratic formula, which again is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, x equals positive 30 plus or minus the square root of negative 30 squared minus 4 times 25 times 9. Over 2 times 25. When I simplify, that gives me 30 plus or minus the square root of 900. Again, that number will always be positive. I have one negative sign, so that's an odd number, which means it's going to stay minus. 4 times 25 is 100 times 9 is 900. All over 50. Nice part about this is everything under the square root cancels. So I simply have 30 plus or minus 0, which I don't need to write, over 50, or 3/5. Now you might take a second and think, how do I only have one solution? We know with the quadratic I should be getting two solutions. This is the case of a repeat solution, and 3/5 would be your vertex. We also talked about factoring it. So up here on a side note, if we were to factor that, it would work out 5x minus 3 times 5x minus 3 equals 0, which when you apply your ZPP, 5x minus 3 equals 0, 5x equals 3, x equals 3/5, again the repeat solution of 3/5. And that's just a side note showing you that it is factorable.